Hey everybody, welcome to part 1 of 9.4 Graphing Sine and Cosine Waves. I have this split up. I'll be doing 2 videos. Part 1 is just for today, and then part 2 will be tomorrow. I split the section, this set of notes up into 2 different days. And for your homework, it's basically be watching this video or following along with the notes that I have provided for you, and completing the you try sections for those 2 days. So I'll go through and again I'll reiterate where to cut off for today, which is day 1, which you should be working on Monday. What we're working on today, we're going to be talking about how to graph trig functions, which you can see some of these bulleted point facts for how we handle graphing trig functions. Here we're going to be dealing specifically just with graphing sine and cosine. There are ways of graphing like tangent. We don't usually, at least for most people, have to worry about graphing any of the inverse trig functions, so cosecant, secant, cotangent. And again, for most of us, we don't have to really deal with graphing tangent. It's really just sine and cosine. Those are the most commonly seen ones anyway, out in kind of the real world, out in other applications. You can see here sound, light, temperature, all of those, because it's some kind of vibration or oscillation of a particle or of energy, or where we see what the technical term is a sinusoidal wave, but it's really just a sine or cosine wave. So if you took physical science, if you took or are in physics or are going to take physics, these ideas, these concepts, you've probably either seen before or you will be seeing. So that will be kind of an extra little piece of familiarity. Some other things that are important for us right now is that in our graph, the x value, our input, is going to be our angle. And with everything that we're graphing, they're going to be in radians. Because like I've said throughout this chapter, radians are kind of the default measurement system in upper level math and in science when you get into the upper level stuff. So in upper level physics and beyond, radians are the most common angle measurement. So that's what we're going to be measuring our angles in here. And then our y value is just whatever the result of that trig function is. So I'll kind of translate that down to how we handle it for you. And we're just going to go ahead and start with graphing our sine. Sine is the most common one. Cosine is just kind of a little bit of an adjustment off of that, which is nice. And just like everything else, when we don't know what the graph of the function looks like, we're going to start out by just finding some points. So there's an easy way of doing this and a harder way of doing this. I want to pick out points on or for my sine value, angles for my sine value, to give me nice answers. And if we can use our unit circle here, we have 5 points in particular, kind of 4, but 5 points in particular, that we have angles that will give us a whole number for our sine. And those ones are those angles that lie on the x or the y axis. So in radians, that was 0 pi over 2, which is 90, pi, which is 180, 3 pi over 2, which was 270, and then the full rotation was 2 pi. And sine, since that is the y value of that coordinate, of that unit circle point, that intersection point, the y value of those angles is the sine value of those angles. So 0 had a height of 0, pi over 2 was up 1, pi was back at 0, 3 pi over 2 was down 1, and then 2 pi was back at 0. Because again, we're talking about the height of our unit circle, or I guess the height of the intersection with the unit circle. So if we do that, you'll notice here I already have my graph scaled how I need it to. 0, 0 is a point, so that's right there. Pi over 2 comma 1 is right about there. Pi was back to 0. 3 pi over 2 was down 1, and then 2 pi was back up to 0. So you can see some of them are going to be prettier than others. Do the best you can. As you can see, mine are not very nice looking right now, at least in the middle part there. But that's the basic of what a sine wave looks like. It is a wave, so you do have what we call a crest, and we do have a trough, which is the highest point and the lowest point. Now, I just drew that section of it. Sine wave is, we have two different phrases for it because, why not confuse you more? A sine wave is periodic or cyclic. Cyclical just means that it cycles. It keeps repeating that graph over and over again. So even though I don't have to actually graph it, and I'm going to just kind of roughly sketch it, it'll keep doing this all the way to the left. It'll keep doing that all the way to the right as far as it wants to. But when we graph them, you only have to graph a single cycle. So a single wave. And again, it starts at 0. It has a crest, which is the highest point right here at pi over 2. This right here is the crest. This down here at 3 pi over 2 is a trough. That's the lowest point in my wave. And then it ends back where it started. So here it starts at 0. It goes up, it goes down, it ends back at 0. Okay, so that's one cycle. That's one single part of the wave. The period, so periodic just means, again, that it repeats. A period, then, is that full wave. So how long does it take to do one full cycle? And in this case, it starts at 0, it ends at 2 pi. That means the length of that cycle would just be 2 pi. That's still an eraser. There we go. 2 pi. The amplitude of the wave, this is something, if you, again, we're in physical science, or if you're one of the physics people, that's probably the one common thing that you've seen most likely. The amplitude is just the height of the wave. Now, it's not from crest to trough, it's from the center, so at rest, up to the highest point, or from at rest down to the lowest point. So you can see there I highlighted that in yellow. This has a height of 1. It has a magnitude of 1 in total. So if you're looking from at rest down to your trough, even though it goes down to -1, the actual height of that, if I just took a ruler and measured that, would be 1 unit. In a sine wave, these last 4 things, you can notice I haven't talked about my domain and range yet, and then my x and my y intercepts. So for my domain, even though, again, I kind of erased this already, but my sine wave continues going as far left and as far left and right as it wants to. So it'll keep just going through and cycling over and over and over again. So this is another one where all real numbers would be my domain. Darn. Just like with almost every other function we've dealt with. Now my range is a little bit different because I actually have a limitation on both my my height, my highest point, and my lowest point. Because it's just going to keep cycling up and down and keep going, that same wave over and over again. The highest point that it's ever going to reach is +1, and the lowest point that it's ever going to reach is -1. So that tells me that all of my y values are going to be between -1 and +1. Now, because we actually have a point at +1, and because we have a point at -1, that's why they're or equal to. So in this case, because I'm starting centered at 0, which is going to be all the ones we see today, the amplitude just gives you what those two values should be. For my intercepts, this is another thing that will be the same for your sine waves until we start dealing with some phase change or some period change. For my x-intercepts here, we have 3 x-intercepts. It crosses 0 at 0. It crosses the x-axis at pi. And then again at 2 pi. So those are my 3 x-intercepts. And again, until we start dealing with stuff where we start changing how big the period is, then that's going to be the case. My y-intercept would be, again, at 0. 0, 0, we can even say. Because there's 3 of them, I didn't list them up above, but my 3 x-intercepts up above would be 0, 0, pi, 0, 2 pi, 0. So that's the basics of my sine wave. Now, cosine is only slightly different than that. It behaves almost the same way with one exception. So if we go back and, again, go back to our unit circle and look at trying to evaluate cosine. With cosine, the only difference is, I'm still going to start with the same similarity. So those same angles that we dealt with before are still going to give us nice cosine values. So there we go. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So those ones, when I'm talking about the cosine, now I'm focused on those x values on the unit circle. So 0 radians, or 0 degrees, has an x value of 1. Right, because I'm talking about its horizontal position. So it's to the right 1, pi over 2 goes back to the center, 0. Pi goes to the left 1, 3 pi over 2 is back in the middle, and then 2 pi is to the right 1. So now if I go ahead and look at the graph of that function, now I'm starting here at 1, I'm going down to 0 at pi over 2, pi is down at -1, 3 pi over 2 is up to 0 again, and then 2 pi is right over here at +1. So now my wave, let's retry that. My wave looks like that. Again, I'm not super thrilled with the right side of it, but that's okay. It still does a full wave. It's just that for cosine at the x equals 0 at the y-axis, I'm starting at the crest of my wave, and then I do one full revolution, one full wave, and then I end back at the crest. So that's the difference. It's really just taking a sine wave and it's just looking at the next portion of it, because again, cosine starts at over 1 instead of at 0 for the x values. So then the rest of these all very, very similar. My domain is still all real numbers, because again, even though I don't have to continue graphing these, it will continue going to the right and the left as far as I want to. If I wanted to draw more cycles, which is again for that single cycle is all we have to represent on the graph. And there, I think when I do that, it makes it a little more obvious that it's really the same wave, it's just a different perspective. So now I'm focusing on just it being shifted over by a half unit. So my range is still the same. I still bottom out at -1 and top out at +1. So -1 less than or equal to y, less than or equal to 1. Cosine is also cyclical. It is also periodic, which means it repeats itself, like I was just saying. My period, the length that it takes to do one full cycle, is still 2 pi, because I still started at 0 and ended at 2 pi. My amplitude, still +1. Now here's the big difference. My x-intercepts, now I only have 2 of them for my single cycle, and that happened at pi over 2 and 3 pi over 2. And my y-intercept, that very first point, happened at 0, 1. And that's really going to be the big focus, is just knowing where those y-intercepts are. For sine, you start at the origin. For cosine, you start at one of the 2 points, so either the crest or the trough, depending on what our graph looks like. Okay. Now, something else that is helpful, I think, when we get to actually graphing them, because we're going to be graphing one full cycle. If you look at it, let's change the color up here. If you think of this in terms of splitting it up into 4 different sections, into fourths, that will help, I think, in a little bit here where we start dealing with some different changes to the period. Because if you look at this next box here, it talks about how we can adjust off of that original sine and cosine function. Because just like with everything else, we looked at the parent graph, we looked at graphing x squared. Now let's see what happens when we have a number out in front of it. Or we dealt with graphing an exponential, so now let's change the base. Or let's change the a1 value or anything like that. So with a sine and a cosine function, so sinusoidal waves, the first two things that we'll look at adjusting are the number out in front of sine or cosine, my a value, and then inside my sine or inside my cosine parentheses with x, if there's a multiplier in there. So here, both of those we're dealing with multipliers. It's going to be either multiplying on the inside or the outside. And kind of the same thing happens with multiplication on the inside and outside as every other function. When we multiply on the outside, that's going to be a vertical change. That's going to be stretching it out vertically. In this case, an a value, which is on the outside, is going to change the amplitude. So that's going to change the height of my wave. So how high up it goes from 0, how low down it goes for the crest or for the trough, down from 0. Now, my b value, which is a multiplier on the inside, is going to stretch or shrink horizontally. So in this case, what that's going to mean is it's going to change how long a full cycle is. So it's going to change the graph's period. Now this equation right here is how we'll do that. We just take 2 pi, which is the standard period, and just divide it by whatever b is. Because again, like everything else, inside is always opposite. So if we see it as a multiplication by b, that means we should take our cycle and divide it by b, because that's how it actually is going to behave. So that's how we'll go through and figure it out. If you don't have anything for a or for b, that just means that it's still a height of 1, and we have no change to my period, so it's still 2 pi. But otherwise, if we do have any kind of adjustments to that, that's where this quarters comes into play. So usually I take one full cycle goes from 0 to 2 pi, and I can split that up into fourths, and that tells me how far to go with each of those different increments, because that tells you where those different intersections happen. Where those are going to be where it's at 1, like the crest of my wave, it goes to 0, trough of my wave, back to 0, and then I'm at the end again. That'll make more sense in a second when we start actually trying to do a problem. Okay, so example number 1. Here we have 2 different adjustments, and we have to figure out, first and foremost, what's our period, what's our amplitude, because that's going to change how we graph our actual function. So in the information I'm given, again, this is my a value. That tells me my amplitude, so my amplitude is now 2. So instead of peaking at 1 and then bottoming out at 1, we're going to be doing that at positive 2 and negative 2. My period is, again, 2 pi divided by my b value. So in this case, I'm dividing by a half, which is the same thing as multiplying times the reciprocal, so multiplying by 2. That tells me that my period is 4 pi. Which my graph here in this case is already scaled for us. I kind of did this purposefully, or this one at least is done purposely for us. So you'll notice that now my graph goes from 0 to 4 pi, because that's how long it's going to take to do one full cycle, and my y value tops out at positive 2. Now, those intervals that I was talking about before, those quarters that we were slicing it up into, because again, each quarter is where we go from 0 to 1 or vice versa, or to negative 1. So to figure out how to find your intervals is your period divided by 4. So in this case, my intervals would be 4 pi divided by 4, a nice easy calculation. That tells you that each interval is pi units wide. So every time I go from 0 to 1, in this case because it's sine, we start at 0. By the time I get up to positive 2, that should happen at pi. And then when I go back down to 0, that should happen at 2 pi. So here again, we'll go ahead and 0, 0, since it's sine, that's where it starts. I'm going up to 2, because that's my new amplitude. Down to 2 pi. Back down here at 3 pi, and then back to 0 for 4 pi. And again, try and make a nice smooth curve. There we go. A nice sine function. Okay. So again, those two pieces of information are really all that we need in order for us to be able to graph. We need to know what my, well, I guess really three things. First, what function is it, sine or cosine? What's my A value? That tells me my amplitude. What's my B value? That tells me my period. Example 2 is now a cosine value. So now I'm going to be starting at positive 1 or wherever. In this case, I'm actually going to be starting not even up 1 because my A value now is a half. So my amplitude is a half. Just take it directly from there. My period is 2 pi divided by my B value, which is 4. So pi over 2 is my period. Pi over 2. I'm just going to go ahead and make room over here. So that's why, again, my graph is already scaled for me. That's not usually the case. And actually, when it's not scaled for you, I find it a lot easier because it's scaled appropriately in terms of how far I need to go. But you'll notice here, this is split up into basically thirds instead of quarters, which is not going to be the nicest for us. So I'll show you how to adjust it and how I would actually scale it. So we still need to figure out what my intervals are, so I know where to put my zeros and ones. My intervals, again, is my period divided by 4. And when I divide by 4, again, that's the same thing as multiplying by the reciprocal, which is 1/4. So I end up with pi over 8 for my intervals. So the way I would usually do this, I know that 0 is my start and pi over 2 is my beginning. So that means halfway between those two. And I even do dotted lines. I'm fine with that if you want to do that for yourself. Because I just, it's easier that way to know where you're supposed to be putting the points. So I know that halfway is there, and then halfway between those two is going to be about right here. Maybe not quite, but that's all right. Doesn't have to be perfect. Because again, when I do this, when it's not scaled for me, I just pick the same point for where my period ends, and it's still just going by nice whole number units. We do have to label our intervals, so in this case, they're not labeled correctly for us. My ends are, but the in-between ones are not. And now we figured out that pi over 8 was my interval, so that's always going to be the first one. The next one should be 2 pi over 8, right? Because that's going to be just another one, which reduces to pi over 4. Next we have 3 pi over 8, which does not reduce. And then this last one is 4 pi over 8, which reduces to pi over 2, and that's already labeled. That should always be your period. Okay. So now from here, we have everything that we need. We know since it's cosine, it starts at the amplitude. In this case, that amplitude was a half, right? Going back over there, that A value was a half, so that's the crest of my wave. At this interval, I go to 0, and then I go down, to a half, back up to 0, and then I end at positive a half for my wave. So for all of you guys who miss my sound effects, for all you who are annoyed by it, deal with it. Ha! That would be my graph. Okay. Because it's pretty similar. I mean, I can do example number 3 real quick, just because it's a little bit different. It's still the same concepts. My A value tells me my amplitude. That's positive 3. Now my B value here is 2 pi. So when I look at my period, it's 2 pi divided by 2 pi, which is just 1. So my period is 1. It does one full cycle, one full rotation, basically, in 1 unit. So this right here is going to be the end of my wave. So splitting up my intervals are just going to be quarters, right? 0.25, 1 half, and then 0.75. 0.25, 0.5, 0.75. This is a sine wave, so it starts at 0. My amplitude is 3, so it goes all the way up there, back to 0, down to negative 3, back to 0, and that is my wave. And again, you can choose whether or not you want to include the actual dotted lines. At the minimum, even if you don't have the dotted lines there, you do still need to label where those intervals happen. So you still need to have 0.25 there, 0.5, and 0.75, along with your positive 1 labeled. So all those different points, you could label it that way if you want to. If you're not a fan of the dotted lines, that's okay. Just make sure you do have that labeled. All right, last couple here. I think we've got 2 more. Yeah, I'm going to skip around a little bit just because this is already a pretty long video, and it gets a little repetitive in a second here. So with example number 4, the one big change here is that you can see there's that negative sign. So even though it's a negative, my amplitude is still positive 2, because that's still the height of my wave. That's how tall it is in units. I don't have any x value, anything in there with my x value, so my period is still 2 pi. Now, if you just look at those 2 values, it looks like there's nothing changed except that my height has a positive 1. But what we have to do is take into account the fact that a negative causes a reflection. Now, in this case, a negative on the outside is a vertical reflection. So all that's really going to happen here is that I'm going to be going down first instead of up first in my sine wave. Because usually, again, we start at 0 for my sine, we go up to positive 1, back to 0, down to negative 1, back to 0. And in this case, since it's negative, we're going to be going down to negative 2, back to 0, up to positive 2, and then back to 0. So it's basically just, again, reflecting that sine wave. So now it goes down first instead of up. It's really the only difference with the negative. Now, with my negative on the inside, what happens is that I'm still going to go ahead and start amplitude of 2 pi divided by the absolute value of negative 1, which is still 2 pi. The issue is that we can do this one of 2 ways. Now, reflecting it horizontally means that I'm going to start still at 0. I would usually go up 1, but if I'm reflecting it, I can even kind of draw it here and we'll do red. This is my regular non-reflected version, right? Starting at 0, up to 2, down to 0, down to negative 2, and back here. That's regular 2 sine of x. But when I reflect that horizontally, I still am going to go up first, down, down, up, and I have this wave. Now, if I continued that blue wave, I'm going to erase my red one now. If I continued that blue wave, I end up continuing by going back down here, here, and there. There we go, beautiful thing. So I actually end up back at the same exact graph as if the negative was on the outside, which is kind of strange, but because of how my symmetry works with these waves and because it's cyclical, a negative anywhere in my sine wave does the same thing. So my sine, if I have a negative on the outside or if I have it on the inside, really all that you have to remember now is that you're going to go down first instead of up. And that's it. Now cosine is a little bit different because a negative on the outside actually does something different than on the inside. So a negative 2 cosine of x, amplitude is still 2. My inside doesn't have anything adjusted, so my cycle is still, my period is still 2 pi. But now, since it's a vertical reflection for my x value, or for my amplitude for my equation here, I'm going to start down here at negative 2, go back to 0, up to 2, back to 0, oops, too soon, back to 0, back down to negative 2, because we have to end the same place we started. So I do this nice little wave. There's a nice ugly curve there on the right side, but I really don't care. Wow, that really is beautiful on the left, ugly on the right. It is what it is. So you can see here, that's a vertical reflection for my cosine wave. It actually does make an adjustment. Now, if I did the same thing for my horizontal reflection, so regular, same information, but I'll do that in red again. But if now I'm horizontally reflecting, my regular 2 cosine of x, whoops, don't zoom in, down to negative 2, back there, up to positive 2, so now if I reflected this horizontally, it's going to still start at 2. I go down to 0, down to negative 2, up to 0, and at positive 2. So you can see it's still the same wave. The cycle didn't break at all. It didn't change directions. That's still a continuation of the original one. So here, if I have a negative on the inside for my cosine, it actually doesn't adjust my graph at all. If I have an A value and if I have an actual number in there, those will still change what my amplitude is and what my period is, but it's not going to make any difference for the graph itself. If I just look at the original graph of that equation. So my amplitude is still 2 pi for the period. And this last little piece here that I'm going to leave you with really just summarizes that, where my negative on the outside, that's always a vertical reflection, so I'm going to be going down instead of up to start with, or after 0. But a negative on the inside, for my sine wave, acts the same as a vertical reflection. A negative on the inside for my cosine wave does nothing to my graph, so you can treat it like a regular cosine wave. I'm not going to go through those pictures because, again, that's just basically what I explained. If you're confused by any of that, obviously it's a video that is there for you guys to watch as many times as you need to. Put it at half speed so you can understand and hear and comprehend all the things that I'm saying really, really quickly if you need to. But completing what we just worked on together, and then the you try portion, which is really just page 7 here. These 1, 2, identify amplitude and period, and then 1, 2, 3 graphing problems is your homework for tonight, for Monday. Okay. If you're still confused after you watched the video, you've gone back through it, you've watched it a couple of different times, and you're still confused, reach out. As always, even though this is the last week and this is kind of the last push to get everything in, let me know if you want to do Google Meet, if you're still just kind of confused on stuff and you want to talk through stuff, or you want a different explanation to things. You just got to let me know. I'm here for you. I'm hoping that everyone is doing well and is going to get all the stuff in. For those who are a little bit behind, for those who are on top of things and have been on top of things, thank you so much. I do appreciate you. I miss you guys. Hoping all is well. I'll talk to you guys later.